Okay, so I'm Danny McPherson. I'm doing a network-based Layer 2, Layer 3 VPN panel. My interest in this is I chair the PW3 working group in the ITF that's chartered to specify some of the encapsulation mechanisms and other things. And what I wanted to do with the panel actually is try and find a good distribution. I wish I'd got a hold of Scott earlier actually, because I was looking to round out the panel, folks that deployed different technology types or encapsulation mechanisms or signaling protocols, and get a pretty good distribution, I think, as you'll see, among different technology types to offer the same service offerings. The GRE-based stuff was the one thing I was missing. So, I watched Scott's stuff a moment ago and wish he would have been on here as well. But anyway, with that, we got Ted on the panel. You all just saw Ted's photograph a moment ago. Shane Amante over here. He's with Level 3. And then Shankar with Quest over here as well. And again, I'm Danny. So, Ted again. Okay, so again, I've already said this. Basically, I wanted to get my goal with this is, these folks are all network operators. I do some of the standard stuff. I've done some of this on the operations side as well, and I still work with a number of folks on that. And so I just wanted to, those folks to share their pain points and what the issues were and what the challenges are going forward and what services they offer and so forth. So. And, again, I already talked about the GRE thing and this other point as well. So some of the questions that we asked. So what I basically did with this panel is specify a set of questions. There are 8 questions here that, go from service offerings like, what is it technically that you're doing today or that your company's offering as a service to what signaling or control protocol or what are your challenges with interdomain or quality of service or class of service or whatever. So this is a set of the questions, and I'm not going to go through them because each one of these folks answers all of these questions individually. So here's the rest, and basically what I'm going to do is I'm going to hand it off to these folks to do to ask their questions, and then I may ask a few specific questions as well, and then if anyone in the audience has questions. And so I know this is the last one of the day. We're 15 minutes early, so if we push it really fast, we can be out of here in 25 minutes. No, I'm kidding. We're gonna be a little longer than that. But anyway, so with that, I guess we're just going to get right on to our first panel member, which is Shane from Level 3. So. And if you have questions, write them down, and we're going to have an open question section just after we finish with this. So.
Hi, I'm Shane from Level 3. Give you a little background on what we're doing. As you probably know, Level 3 offers Layer 2 VPN services. I'm not really here to talk to you a lot about those today. If you want to argue about that stuff, I point you towards Luca. You can have some conversations with him about the decisions that were made there. So I'm primarily here to talk to you mostly about the IPVPN deployment that we've just recently done, approximately 6 months ago. As far as the service offerings that we have, basically everything over MPLS. We don't have a VPLS offering. Approximately 10% or a little bit over 10% of our traffic on our backbone today is covered by VPN products, which is pretty impressive in the short course that Level 3's had these products out there. As far as what transport we're doing for the underlying VPN technology, MPLS, why? Mostly because it was already there. Secondarily, fast reroute is a very important consideration both at the edge and within the core. So that was an extremely big motivator for the choice of MPLS. Ted's probably going to talk to you a lot more about L23v3, but we're keeping an eye on that. It's a very attractive technology. Unfortunately, it's not widely available, and by that I mean there's not consistent across the board support from all vendors. But other than that, there's excellent data plane security. Although the cookie field and sequence numbers are both optional, you throw those things in there, gives you excellent data plane protection, which it'd be extremely useful for, say, off-net backhaul where perhaps you don't want to impose the overhead of, say, IPsec, for example. Number 3, what type of provisioning control mechanism are we using? As far as the Layer 2 VPN stuff goes, targeted LDP for distributing the labels for the pseudowire services. It's a point-to-point service, so why not have a point-to-point signaling protocol? As far as IPVPN goes, MPBGP rules the world. Why? Well, BGP is ideal for carrying around buckets of just about everything, so why not use it for this? Ultimately, though, what it boils down to is there's innate policy mechanisms in BGP which make it ideal for essentially building the communities of interest that form the different VPNs. Also, if you consider that all or the majority of the VPNs attached to a large number of the PEs, flooding the reachability information from one PE to all the other nodes in the network is, perfect for BGP, as it were, and finally it's already used for the PE to C dynamic routing protocol. So, hey, why not use it for that too? As far as number 4, PE challenges go, this is where some of the some of the things really start to get interesting. There's this customer and marketing perception that the VPN PEs have much higher availability than internet PEs. If you look at from an IPVPN standpoint, people want to be able to offer a converged voice and data on single circuits and through a single backbone. Another big concern is that vendors and other carriers tend to market the layer 2 VPN services as X over private line or X private line, which infers as TDM-like availability, which, as you've seen earlier in some of the IP fast reroute talks, that certainly isn't the case. It takes a lot of work to actually accomplish that. As far as edge-to-edge LSPs, yes, they're there. We're doing make before break on PEs, obviously, to increase availability. RSVP fast reroute is extremely important in the backbone to increase availability as well. And as far as one of the other major challenges in the operational realm is as far as the VPN PEs to Ps, doing capacity planning on those links is more challenging because from a best effort PE, all you're looking at is the size of the link and just growing that upwards. With putting in sort of rich class of service or any class of service, if you want to play around with some of the schedule allocations and buffer sizes and all the other fancy knobs you've got in QoS, well, it's certainly more to play with. Number 5, vendor interoperability. As far as layer 2 VPN stuff goes, there's been some occasional code rewrites which make for some fun and interesting things, but usually those get caught in the lab before things make it out to the production network. Just a minor point about LDP or BGP, as various vendors have their own preferences. Really the only point here is both work, both do the job. The main point here is if you start with one, you're probably very unlikely to go to the other, so it'd be nice for everybody to have both. IPVPN, as far as interoperability with MPBGP, largely that's not an issue. I mean, vendors have been doing BGP since practically the dawn of time, so if they can't make that work, we've got larger issues. As far as the bigger challenge is when you start getting into per packet QoS with IPVPN, that's certainly where a lot of the challenge comes in. Making class of service work across multiple vendor platforms with different implementations is the biggest pain in the neck there is as far as an IPVPN service with any type of QoS issue. Again, if you got a single vendor, probably not that big of a deal, but when you start to bring multiple vendors in, everybody has their own unique ways and knobs of turning things, so it makes it harder. Some relevant standards work. I'm only going to touch on a few of the more important things. C2C member verification, draft that is a working group item in the Layer 3 VPN working group. It's probably, in my opinion, a precursor to some of the RPSec work, which might ultimately solve these issues, or at least a subset of RPSec. So as we sort of wait and work on getting that pushed out the door, we can work on this. Again, on the QoS side of things, one of the biggest challenges is, as far as, especially when you get into speaking with downstream customers and other carriers and you want to do, say, an option B or C interconnect or an option A interconnect, having consistent DSCP markings across borders is just extremely challenging. One of the drafts on here that I mentioned, this draft Baker diffserv, is a good start at mapping applications to various service classes, markings, and class treatments. Certainly there's a lot of different classes that they define in there. It's not expected everybody's going to use every single marking that's out of there or have the same, but it'd be nice if we could all agree to the same sets of markings to largely make that a non-issue. And then finally, multicast work is essentially just beginning in the IETF Layer 3 VPN working group. So 2 more questions. Security considerations. Separate VPN and internet PEs is a strong marketing advantage, and also operationally to be able to separate BGP from the internet IPv4 unicast convergence from VPN v4 convergence. Also, it reduces accidentally putting internet ports in VPNs and vice versa, eliminates the risk of DOS attacks on VPN PEs. Ultimately, though, I still encourage customers to analyze their data sensitivity and use firewalls and/or IPsec at their VPN edges. In fact, one of our IPVPN customers today is using IPsec for all data transport across their IPVPN services because they deem all information that they're sending that secure, and they're even wrapping it in a layer of application security, SSL security as well, just for fun. Another thing we see in RFPs is a BGP-free core. Today we're not, but it's something obviously we're looking at as well as a number of other people are. I put that in quotes because generally the requirements from the customer are really defined in those 3 words there, but when it really comes down to it, you sit there and you talk to them a little bit more and you explain what are some of the larger concerns. They tend to get it and move forward. And then finally, this is more of just sort of a point and maybe even a question for the audience, but private customer-only routing registry for IPVPN routes. A lot of people that I talk to seem to think that max prefix limit is enough, but on the other hand, it's useful to be able to use a routing registry to help customers actually assign, say, route targets to build arbitrary topologies within their VPN as well. So it's sort of a give and take. People that want to sort of treat your IPVPN like a sort of generic frame service, just send all the routes they want to you and let things fly, they tend to be very opposed to a routing registry. Other guys that want to have more control and they have a better understanding of their network don't mind a routing registry. And last but not least, the manageability concerns. Like I said before, class of service is hard. To steal a little bit of a quote from Edison, class of service is really 1% inspiration and 99% perspiration. Customers say, hey, I want it, but the majority of them seem to be converting from legacy frame and ATM networks, and they don't really have a handle on what different service classes they really need and what their schedule allocations might be, and et cetera, et cetera. Plus, they also don't take into account that it's not just a fire and forget kind of thing. You want to set it up, and you also have to keep an eye on your traffic and modify things as appropriate. And then last but not least is some of the people that you sell this into, eBGP is a foreign concept to them, and so educating them on some of those things has been a challenge. So that's pretty much it. Shankar.
Thank you, Shane. My name is Shankar Rao, and I'm from Quest, and I'll try to cover the same questions that Shane did for us very quickly. Before I begin, I'd like to give you a little bit of introduction about Quest, for those of us who don't know what Quest is. And Quest is a little different than the other companies that are represented in this panel, in that we are an ILEC in 14 states. So we have strong regional networks and also a nationwide IP MPLS backbone. The Quest network is really a single global AS, about 23 major POPs with OC192 circuits and different regional POPs with OC3 and OC48 type circuits. One of the good things that we have going for our favor is that we built this network starting from the optical layer all the way to the IP layer within the last 4 years. So we did not have to deal with a whole lot of legacy issues and having to build upon an architecture that had other limitations as well. In the next slide, I'd like to review very quickly the history of MPLS at Quest. So we didn't choose to deploy MPLS for traffic engineering or VPNs initially. We deployed for fast reroute. And this was primarily for the application where we were using the IP backbone to replace the TDM trunks between our class 4 voice switches. Quest is also a phone company. So our goal there was to leverage our IP backbone to carry a long distance voice traffic. And clearly, fast reroute helped us a great deal there. And most recently, when I checked, we're carrying about 2 billion minutes of long distance traffic on this backbone. So for those of you who are wondering if IP networks can handle that, we can tell you that they probably can. So on the first question, we've had a mixture of layer 3 VPN services for the last few years. We actually started by deploying IPsec-based network VPNs in about 2000. And in 2002, leveraging the experience that we had with MPLS fast reroute deployment, we also deployed the MPLS-based layer 3 VPN service. As far as layer 2 VPNs are concerned, Quest also has a nationwide ATM network. Now, this ATM network offers classic layer 2 services, such as ATM and frame relay. We're not yet offering MPLS-based layer 2 VPN services, but we're looking at this closely from a couple of perspectives. The first one is infrastructure consolidation. Like I said, we have a nationwide ATM network, and our goal is, just like we're carrying voice traffic on the IP backbone, why don't we replace these trunks, these TDM trunks between our ATM switches, also with an IP core? So that is one application we're looking at for MPLS layer 2 VPNs. And obviously, we want to use that experience also to offer it as a service to our customers, that as another option for layer 2 services. Now, there are a couple of different perspectives on this layer 2 VPN concept. For example, I've talked to some of my customers in the financial services industry, and it seems like these people live in the Stone Age, in the sense that they use only dedicated circuits everywhere they go. And to them, these dedicated circuits are like the gold standard in terms of reliability and operational maturity, and we just simply cannot argue that. At the same time, SONET is also seeing a revival in terms of technologies like LCAS and VCAT, which are making it possible to squeeze more capacity out of these SONET networks. Not only that, the pricing for these private LAN services, as most of you might know, has gone down dramatically in the last few years, right? So where does all this leave us? Although it is unfortunate for all of us, the reality is that enterprise customers really want layer 2 services, in my opinion, simply to have a cheaper alternative to TDM. At the same time, not wanting to give up TDM like quality, right? So that is a really difficult balance that we must find. And then there are those that I talk to that are simply comfortable with their ATM and frame relay services, and they see absolutely no need to migrate, right? What's good, it works, why should I do anything different? In my opinion, the couple of new services that layer 2 VPNs, MPLS layer 2 VPNs offer are things like layer 2 interworking and possibly VPLS. But then these come with their own set of operational problems. So, so in summary, I think that layer 2 MPLS VPNs are still not yet at their peak. Encapsulation methods. We chose MPLS, again, for its fast reroute capability, and the other vendor interoperability is also of very significant importance to us. So MPLS seems to have the most advanced capability in terms of support offering vendor interoperability. Not only that, we want to leverage the investment that other carriers and vendors have made in technologies. So clearly, if Level 3 is scaling this on their network of how many our nodes, we want to benefit from that operational maturity as well. And although we don't use traffic engineering, it is an option that we want to consider and keep in our back pockets if we have to use it at some point in the future. In terms of provisioning and control protocols, not very different from what we heard from Shane earlier. LDP for signaling, for LDP for signaling layer 3 VPNs and with MPBGP, and we're also looking at LDP for layer 2 services as well. And the key issue there really is being able to scale these things. For example, if you do have a fully meshed RSVP, LSPs between your PEs, then as your PEs tend to increase, you have scaling problems there. In terms of PE challenges, I think this is a very good question, and I believe that offering VPN services on these IP backbones or MPLS IP backbones is really challenging some of our fundamental architectural assumptions. Let me talk about a few issues that I believe are important. The first one is security. When we talk about security, when you talk to classic layer 2 VPN customers, so ATM and frame relay customers, the notion of privacy in a classic layer 2 network is that the network is separated from the internet. So such customers want to be convinced that they are migrating to a new network which meets that fundamental requirement. Now there are a couple of, or I'm sure there are several approaches from an architectural standpoint to solve the problem. One is to build an island of a network. That is a network that is not connected to any other network at all. Now, the problem with this is that enterprise networks are typically not self-contained, right? They have to serve their internal applications, they have to connect the remote offices, and they have to serve their customers for applications like CRM or supply chain management. And this means that they need to have the ability to bring in extranets very easily. And these extranets may not be connected to the enterprise VPN through this carrier VPN product. And another increasing trend that we are seeing is the mobility. More and more users are working, connecting to the corporate networks from wherever they are, whether they're at home or traveling. Now, clearly, if you have a network that doesn't talk to the internet, it's hard to support those requirements. The second major issue is about scalability. We've all grown up with the golden rule of keep things simple, but it seems like we are having to kind of brush that rule under the carpet a little bit. The third issue is reliability. It wasn't very uncommon, as recently as a few years back, for us to have extended network outages due to various reasons, software glitches or routing problems. And an approach that was popular was what I call reload and pray, right? So just reload your routers and hope that everything comes back as normal. Now, we all know that if you try that today, it wouldn't be a very good move for your career, right? So the point of this is these networks are carrying a lot more than just internet transit traffic. These networks are carrying voice traffic, they're carrying VPN traffic, which translates to business application for customers. So enterprise customers ask for 5 nines reliability. And the question is whether we can deliver that. The fourth issue is of network transparency. What I mean by that is how can we ourselves have the tools to know that the network is doing what it ought to be doing. These are the OAM type capabilities. At the same time, being able to give customers the visibility so that they know what's going on within their VRF topology. Vendor interoperability. So in terms of vendor interoperability, like Shane said, I think the layer 3 MPLS VPN services are pretty interoperable. We don't see any issues with that. I think as far as layer 2 VPNs are concerned, that is still an issue. And what customers really want is carrier interoperability. So many customers that I talk to are really looking for the carriers to provide them a solution which lets them connect their remote locations, wherever they might be, to multiple carriers. And unfortunately, I don't think the carriers are doing a pretty good job at delivering that service, Quest included. Now, there are various other, more than technology issues, there are other political and trust issues that need to be overcome when we talk about inter-AS MPLS VPNs, and I believe that's where this vendor interoperability question becomes more important. And when you talk about bringing together two environments, which might be built with MPLS versus L23, what common control mechanisms do we have to build these inter-carrier MPLS VPNs? I don't know. In terms of the standards work, it seems to me that the standards process that we have right now is very laborious. I don't see any operators showing up at these ITF meetings. It's a lot easier if you're an operator just to talk to your vendor, and hopefully they represent you appropriately. So I guess we all vote with our wallets here. And in my mind, most of the standards work seems to be academic than practical. We really need to get down to solving problems and overcome the issues that vendors have. But like we all know, there are other considerations that probably make this very difficult. And a recent trend that I've noticed is that we have more and more standards bodies. I don't quite know if this is the answer to solve our problems. In terms of security considerations, what I'm trying to depict in this picture is a conceptual way of how IP backbones were built in the past. So if you think of this, it's all one plane. It is one plane that supports VPN traffic, voice traffic, and internet traffic. So like we all know, if there is some instability on this one plane, it'll probably affect every service that is running on it. So I kind of liken this to an open loop system. That is, for the stability of this system, there are external inputs required, external inputs that you do not control. What we want our core networks to be like is like a closed loop system. What I mean by this is a system that is independent by itself, does not rely on eBGP or some other external inputs for it to route packets. So the next slide, I'll try to describe kind of a different architecture model, which I believe makes more sense. So at the foundation of this architecture model is a core backbone, which is our IP MPLS backbone. And all this layer really needs to do is to deliver TDM-like transport to the higher layers. So this layer needs to be as good as a TDM layer, except that it is packet switched. The next layer, what I call the private layer, is the layer where we transport all of our non-internet traffic, things like VPN traffic or voice over IP. Now, these are the kinds of applications that do not require the internet to be around to work. So therefore, this layer will probably not have external BGP peering sessions with other external entities. On top of that, we have what is called a public layer, and this layer, as we all know, is the classic IP transit layer. So in this layer, you peer with external partners, and you're subject to all kinds of BGP flaps or whatever else goes on, and you're really not guaranteed that this layer will survive if the internet goes down, because clearly this layer is dependent on the internet. And in a way, to bring in these external traffic and to bring in these remote access employees that you might have into the corporate intranet, which is residing on the private layer, you might want to have a layer of firewall capabilities that let you do that securely. And finally, with some of the traffic engineering capabilities that MPLS offers, it might be possible for you at the core layer to separate out, from a data plane perspective, your internal versus external traffic. So you have, as an insurance policy, not necessarily something that you practice all the time, a way for you to prioritize certain kinds of traffic if in the unplanned event of an outage or things that you cannot model. If certain events occur, you are protected. In terms of deployment and manageability concerns, I believe that technology is the least of our problems. I mean, the control-del approach to solving routing problems is really not that widely used. In addition, traditional technology boundaries are losing their relevance. When we talk about layer 3 MPLS VPNs or layer 2 MPLS VPNs, you're no longer talking about ATM services or frame relay services. You're talking about a heterogeneous network that might be using a combination of these technologies to build enterprise networks. So a customer might have a layer 3 VPN with ATM access in some locations, frame relay access in some other locations, DSL and Ethernet in some other locations. So the traditional model is of building networks around technology or building your support and operational systems around technology doesn't work really. I believe that for carriers, the people and the systems need to develop an inclusive view of their enterprise customers, understand that their VPNs are really made up of multiple technologies and are really carrying multiple diverse applications. So that, unfortunately, I think is where a lot of carriers might do a lot more work. And that is all I had in my presentation. I'll be happy to take questions whenever we're done. Thank you.
Thanks, Shankar. Hi, I'm Ted Seeley from Sprint. For those of you who don't know me, I'm going to try and go fast here. I don't want to get between us and beer and gear. So I don't want to get shot. Little history before we get going here on service offerings. Sprint took a different approach than most people did in the industry. Being an all IP provider from day one, going all the way back to 1992, we never did overlays, we never got sidetracked, took detours, whatever. But we stuck all IP all the time. So we decided to offer all of our services over a native IP network. So we offer frame, ATM, Ethernet. We're starting to offer private line services for customers who want them. And of course, layer 3 VPNs for all of our customers today over IP. One of the points Shankar made about enterprise customers, and this is a big driver these days, is your layer 2 VPN customers are wanting a migration path forward off their layer 2 networks onto layer 3 VPNs, but they want a way of doing it in a way they can just more or less flip the switch and go layer 3 when they're ready. So you have to have the ability to offer a native layer 2 VPN offering doing frame and cap on your IP platform and offering this migration strategy forward. And it's a huge driver, and it's actually a bigger pain than layer 3 VPNs are to doing support today, because you have to maintain gateway services and functionality back to your legacy frame relay platforms, ATM as well, though there's not nearly as much ATM. So what are we using today? We're 100% L2TPv3. Because like I said a minute ago, no MPLS, no LSPs, no LDP, none of that stuff. And it offers an inherent any-to-any connectivity already today, so we can do frame to Ethernet, frame to ATM, ATM to Ethernet, et cetera, for the customers who want that. So I'm sure I'll get questions in a minute on that one. But so provisioning and control, this is really important stuff. What you're running in your core doesn't matter, because all the stuff we're talking about up here are all edge applications. It's all a 2547 biz, or it's a frame relay variant of it, or an ATM variant of it, running in an MPLS switching process on the edge router, where all this stuff is taking place. So again, this is also why we stay IP in the core. And as long as you're compliant with the standards, you can pretty much interoperate with anybody else out there. Internal on net doesn't matter. If you're going off net, it does matter. Again, this is where you have to be standards compliant. But what we see from an interoperability perspective today in that arena is pretty much primarily back-to-back VRFs today, and we're beginning to see some interest in eBGP with label exchange. But again, as long as you're doing this on the edge and you're compliant, it doesn't matter. I got to keep reiterating that. A lot of people think you have to do this stuff all the way across your core, and you don't. It's purely an edge application. So the PE challenges. So we like level 3, we have a dedicated PE box in most of our POPs today just to do layer 3 VPN services. Layer 2 services we do pretty much anywhere we want. And that's because you don't have an IP address on it. That doesn't mitigate the security threat to the platform, but the port itself isn't DOSable. The biggest challenge you have to all this stuff are the internal provisioning systems. You being a big giant telco, we spent enormous amounts of resources to build frame relay provisioning systems to track customers, et cetera. We didn't do all that for the IP base yet. Now we have to do that, and it's pain. It's a real pain. And again, I'm going to reiterate, as long as you comply with standards, interoperability is not an issue. Right? I got to keep reiterating that. Vendor interoperability, that doesn't apply to us. So we'll blow through that one. That was quick. Standards work. Shankar said something that I disagree with. Vote with your wallet. Don't do that. For those of you who don't work for Cisco or Juniper, et cetera, in the room, go to the IETF, get involved, tell these people what they need to be doing. It's being driven by the vendors now, and we got to stop that before it's too late. Speak up. So, in that, now let's move on to standards. L2TPv3 is a newcomer. The RFC is sitting in the editor queue still, if I'm not mistaken. It might be out. It's moving forward in all the other relevant working groups, whether it be MPLS, L3VPN, L2VPN, et cetera. And eventually, if Danny isn't so lazy, it'll make its way into PWV3. So, told you I was going fast. Security considerations. Shane touched on it. L2TPv3 offers you a cookie and session ID, which is really cool. Session ID, because you can demux on it, gives you some distributed nature to the protocol. The cookie has to match or the packet gets discarded. Cookies aren't security. Don't confuse it with security. Security is end-to-end encryption. If you need security, you need end-to-end encryption. There's no ifs, ands, or buts about that. So our Ps are standalone, as I said earlier. It adds isolation capability, but it doesn't remove the DDoS vulnerability. Nothing removes DDoS vulnerability. If your box is addressable via the internet, it can be DOSed. Bottom line. Fewer protocols, we think, leads to lesser complexity. We've always built our network with the KISS theory, keep it simple. And it also implies fewer holes, fewer things to break, fewer patches required, fewer, there's this bug and this part of the switching code you got to worry about. So manageability concerns, yeah, VPNs are a pain, as Shane pointed out. And again, it all comes down to provisioning systems. The routers do it. You can get in there, type it up, create, address family, VRF, blah, and you're done, right? But you got to track the customers, and that's the hard part. And some of these VPNs are huge, thousands of sites. So that's the hurdle we see there. We don't have any manageability issues from a protocol perspective, but we also have the advantage that we aren't running another switching protocol on our core. I don't have to worry about what LDP am I forwarding down. I'm forwarding down the route. I'm forwarding down the best route based on the metrics, which makes it simple. And we like it that way, and we're going to stick with that. One thing I want to point out, Shane Carr might have said it. I'm Shane. Did they talk about running a faster route in the core? We're going down the path of focusing on fixing the protocols along the lines of what Dave Ward and Leah were talking about earlier. Let's fix the protocol. Let's put the capability in the protocol itself. Let's not run another protocol on top of the protocol to solve a problem. So that's where we're at. And that is it. Questions from the audience?
This is my slide.
Danny, it's all yours.
Come on. So yeah, actually, let's go ahead and do. I have a couple of questions for the panel members as well. But does anyone out there have any questions they'd like to ask anyone at the moment? No one. All right. I'm going to get interactive here. All right. So actually, before I ask them their, oh, good. Yeah, go ahead. State your name and.
William Lipson, Elan Networks. It's not much a question, but I want to know if you use IPsec with your VPN implementations.
For everybody?
For some clients, and how well it worked. And how much you think it's important for when you're implementing VPN over.
Yeah, we offer an IPsec VPN offering as well. Where you see a lot of that is you see a one-arm bandit solution where customers want that capability as an option to get to the internet. So they want a VPN running an IPsec and they want access to the internet through it. So that's where we see that. But we do offer it. But the demand isn't as much as it is for the other services.
So people won't just clear VPN and they trust that nothing is going to happen to their packets. And
Well, let me caveat that. We have two networks, so to speak. We have a totally private network where we have no internet connectivity, and we have the actual SprintLink network, which is internet. So we have customers come and ask, and they want that service on the private network, which has no internet connectivity. So we don't have to offer an IPsec VPN. They feel secure on that enough as it is. But we do have an IPsec service offering on the internet network as well.
Okay, Shankar, you want to take a?
Sure. Quest offers an IPsec-based network-based IPsec VPN as well, and we also offer managed services for you to do encryption. And really, I think if you want to use IPsec, it has to be end-to-end. It doesn't really add much value if you're doing it in the network. And more likely than not, customers that are connecting in extranets or supporting remote access services tend to use IPsec to bring in those client applications.
Okay. And Shane, do you have anything?
Yeah, so Level 3 doesn't offer an IPsec-based service at this point in time, but what we see is the way that the IPVPN service is marketed is claimed as equivalent to the security of frame and ATM. People tend to buy a lot into that and don't tend to look underneath the covers, yet whenever I speak to customers, I'm still letting them know that they should definitely take a look at what their data security needs are and deploy IPsec if they need it. I think the problem they run into is they start to look at what the price is to add IPsec accelerators to get the performance that they need out of their solution, and they end up saying, well, good enough is good enough. So.
Okay. Any other questions from the audience for the moment? All right, so I've actually got a question for you. I was wondering if I could see a show of hands of how many folks in the room have either deployed or are in the process of deploying or actually buy layer 2 or layer 3 VPN services from someone today. That's it. Okay, I thought I'd see more hands than that actually. So the rest of you are just still reading email, so that's fine. Just keep reading your email. So yeah, actually, I had a question for Shane first, and what I was wondering is regarding you mentioned in your slides multicast and the standards work going on in the IETF. Are you seeing native, or I guess as native as it gets with an emulated service across your infrastructure, but native multicast requirements from your customers in RFPs or how they communicate those? And the second part of that is actually, is there some way you'd like to see that work go in the IETF?
So the answer is, we haven't been at the layer 3 VPN game that long. So I guess our data point, you should take our data point with a grain of salt. We do see customers that ask for it, but the majority of customers that are asking for it don't have multicast actually deployed in their network. Now, I said the majority. There are some of the larger customers that actually do have multicast inside their existing layer 2 VPNs today. So it is a critical requirement for them, and obviously they don't want to run GRE tunnels to put their multicast through that network. So I guess the short answer is we'll probably be seeing more and more of it as time goes on, but for right now, the demand has been kind of low, actually.
Could I add something here, Dan?
Yeah, absolutely.
I'd like to add something to what Shane said. We see a lot of multicast demand, and actually, I think there's been more adoption for multicast in the enterprise community than in the internet itself. So it's interesting that you don't see a lot of demand for it, but we see a tremendous amount of demand for it. So
It's good to know.
I thought I'd throw that out.
Round it up.
Sure. From my perspective, I would tend to agree that multicast has a greater application in enterprise networks than in the internet. And we do see requirements for that. And, unfortunately, the ways that this is implemented seems to be so crude right now.
Okay. All right, Shankar, a question for you actually based on something you said in your slides. Just wondering, and this will go on to you folks as well, but you mentioned political issues or ramifications of doing certain things. Are there political or regulatory, I think it's kind of unique for you, but it also applies to them with your 14 in-state, in-region kind of stuff versus, the global backbone network. But, of the layer 2 and layer 3 VPN services, what do you see as, the predominant political or regulatory implications that dictate engineering of the infrastructure? Does that make sense?
I'll try to see if I can answer that. Where Quest is the local phone company, we are regulated heavily. So all of our frame or ATM services that we offer in region where we operate as an incumbent are regulated. We have to file tariffs, price it, and give everybody a chance to reject our pricing, things like that. So I think from an engineering perspective, the challenges are quite different. In region, we have very dense networks. And, on the national side, the network is obviously a lot more sparse, fewer routers that are involved. And Danny, I don't think there are necessarily any regulatory issues, regulating us on the national network. And I really don't believe there are any significant engineering problems that arise as a result.
So just to follow up on that, I think I saw something regarding India and VPN service offerings and an additional fee they were going to impose on network-based VPN services, that sort of thing. And I was just wondering if any of you have actually seen any of that on your on your service deployments or service offerings. So.
In terms of someone imposing a premium or a tax?
A government-imposed tax, or absolutely.
That is a very interesting question. In fact, over lunch I was just discussing that we have now a new FCC commissioner or a chairman, and it's going to be interesting to see what his policies will be. I think the bigger question there, more than VPNs, there is a lot of regulatory pressure on this whole voice over IP situation. So I think it's going to be very interesting from an RBOX standpoint. We feel that we are unnecessarily burdened by the taxes that we are required to pay on these regulated phone services, which the cable companies or these new companies like Vonage do not have to pay. So I think that's going to be something that we're going to be seeing being brought more to the fore.
Dave, you want to say something before we move? Oh, I'm sorry. Actually, state your name and.
My name is Todd Christel, SpringNet. We are a metro provider. We have a native GigE backbone, and so far most of our business has been business to business type on layer 2. Customers like it because it's simple, but now the customers are looking to go off net, and all of a sudden now we have something that is essentially encapsulated with a Q tag that we need to offer up to carriers to get it off the net. And I'm just curious what kind of transition technology or what you think might be the best answer to expand our area coverage.
Okay, so I think the question, if I can rephrase, was what's the best way to move into interdomain layer 2 VPN service offerings?
When we're essentially starting out as a native Ethernet offering. We don't have legacy ATM or frame revenue streams, so everything we do is pure IP. So.
Okay. Any of you guys want to add something? Just thoughts on interdomain in general, I guess, would be that.
If you're doing Ethernet and 1Q tags, that makes it kind of easy to just do back-to-back VRFs and have the carrier tunnel it across to wherever the other endpoint is. I didn't hear you mention what routing protocols you're running, whether you're doing MPLS or whatever, but you can also do eBGP with label exchange, does the same drill. However, you lose some granularity in filtering and in policing the traffic today. In the future, that will be there, but I don't see it there right now. You want to add something, Shane?
I don't really have anything to add. No.
I thought
Did,
you were too.
but before we continue,
Did
I think
that answer your question? Did that? All right.
okay,
That's
good.
important to
So
ask.
so before, I think Susan's probably got a question from someone. I actually wanted to see if Dave, was your question related to the previous to Shankar's regulatory and so forth?
No.
Okay, then do either of you have anything to add to Shankar's response to that before we go to the next question?
I haven't run into any policy or regulatory issues at this point, so no.
I would just voice, I would agree with him. I haven't seen any VPN specific taxes imposed by other countries, but I do see that the voice over IP stuff is a threat to some of the revenue stream for the PTTs in offshore, and I do see that as a risk.
So, Dave, if you don't mind, if I could let Susan go since she's holding her laptop and
I don't mind.
just keep waiting there, buddy. We'll get to
I'm
you
not going
eventually.
anywhere.
About
This-
7:30. No, all right, go ahead, Susan.
This came into our old questions address. It's from Jim Boswell at Roadrunner/AOL. Roadrunner/Time Warner. I still get those companies mixed up even after last fall. Sorry. Two questions, or one question. What recommendations for point-to-multipoint or multipoint-to-multipoint VPNs for a non-MPLS enabled network? And he explains, we've been using L2 TPv3 and it doesn't scale very well.
Interesting. Okay. I guess that's a question for me.
Yeah, that's what I was thinking. I'll give you that one too. And
I don't know why they would say that. We have thousands of VPNs distributed with it today already. We don't have a scaling issue with it. He's not running MPLS, so his options would be that or GRE, I guess, or he could do IPsec. But I don't think Roadrunner or Time Warner have the service offerings today. I'd be curious just to have some more detail around that, but.
So just to add on to Ted's comments, I know that there's been a draft out, and I don't remember if it was in the Layer 2 VPN working group or pseudoware or one of those, basically talking about distributing L2TPv3 session identifiers, cookies, the whole 9 yards, using something, presumably BGP. Presumably that could be used as sort of a service discovery mechanism at PEs, but obviously that's probably going to be a ways off, but that might be something he can look at and follow and get him there.
I want to add this. I would assume he's doing Layer 2 VPNs with his question, because for Layer 3 VPNs, it's the same switching code that native MPLS VPNs use. So I don't think anybody has a graceful scaling solution to Layer 2 VPNs. They're just not, they just don't lend themselves to that very well. So.
all right. Yep. So yeah, go ahead, Dave.
Thanks. This question's about layer L2 kind of pseudo wires. And what I was wondering is if anybody who has a lot of pseudo wires running through their networks, like thousands, have them aggregated someplace in the core, what kind of network management or proactive network management do you have in mind? And the reason I'm asking is because basically the whole alarming system for those pseudo wires as they travel through someplace like an OC192 in the middle of your network, if you lose that and you lose some number of those pseudo wires, locating where that fault, where some of the faults that are correlating faults and all of that sort of stuff seems to be a scaling problem. And I'm just wondering if, one, if you folks think that is an issue, and two, if anybody's run into it yet.
So let's Shankar, do you want to take that one first, and then
Sure.
see if these guys.
We do not yet offer pseudo-wire services on our backbone, but I think, like I mentioned in my presentation, it's a big question. And it's not just about carriers knowing what's going on. In many cases, your customers want to know what's going on too. We hear that constantly, and I don't quite know if there's an easy way to open up our management systems to customers to give them a view of what's going on with their network. But I believe that that particular issue needs a lot more work.
Oh, by the way, it's exacerbated by the inter-domain case, right? It's hard enough in the inter-domain case, but it gets
Absolutely.
worse.
Absolutely. Okay. Either you have anything to say towards it?
I'll reiterate what Shankar says. I think a lot of that work is still being fleshed out, David, as far as the single linear control and alarming mechanisms, OEM, if you will, for pseudo wires. I would like to hear the working group's chair's comments on that. But it's not there yet. You're right. And it's a good point. You're at the mercy of your reconvergence or fast reroute if you're running that to reroute around the failure. And there's no way to signal back that it's happened. So it's a good question. It points out a gap that exists today in the technology.
Okay. You want to go ahead and add something, Shane, and then we can have.
So I was just going to add, that fast reroute tends to take care of the majority of the problems that you'd end up having inside the core of the network. Make before break tends to work a lot on the edge. There's also a layer of operational procedures that need to be developed as well, such that when performing scheduled maintenance on boxes, that you're not just turning off the power, waiting for things to converge and hoping for the best. Obviously, you want to try and peel traffic off to a redundant path where possible. So while not perfect, it's worked through to today, and we're consistently providing performance that's meeting or exceeding the SLAs that we have offered to our customers.
I would second that, and from the experience that we've had with having deployed fast reroute, it's really been transparent to our operations people. But I think the question is, at some point, your customers will ask for the, specific reporting capability on their LSPs and on their pseudo wires across the network, and that might be a challenge.
Did that finish it for you, Dave? You okay?
Yeah, thank you.
Great, thanks. All right, so yeah, name and.
David Barak, SBC. Are you seeing are any of the panelists seeing any desire for layer 1 services over MPLS? Or I should say for pseudo-wire layer 1 services?
So from my perspective, no. The customers that we primarily talk to are, in fact, moving towards layer 2 to layer 3, actually. Those folks that seem to want layer 1, we tend to steer in the direction. It tends to typically be for probably like voice applications, circuit PRI, say, coming out of the back of a PBX. In that case, we tend to steer them towards a media gateway solution off the back of the PBX. It's IP at that point. I can either do layer 2 or layer 3, and I'm done. That's really the most I've seen recently.
I would say yes, we are. And I would prefer to see the world go in the direction that Shane just said, but it's not going to. There are going to be people who still want circuit services. And so we're starting to get demands for that. I'd say that realistically doing it in scale is still several months to maybe a year or two away. But yes.
So just one more follow-on point, too. I think when you start to think about essentially layer 1 TDM services over MPLS, what you also want to think about and consider is whether it's economical for you to do that. There is, put it this way, there's a lot of work to make some of the layer 2 services work over MPLS. Going down one more layer is even harder. So it begs the question of financially and operationally, whether it makes sense to even attempt to do that, in my opinion. So I would try to get it up to at least layer 2, if not layer 3, if possible.
Shankar?
I'd like to comment on that. I think what has happened recently in the last few years is the pricing for TDM circuits has gone down dramatically, and that continues to happen. So to reflect on what Shane said, it's a question of economics. Why would you settle for something that isn't TDM when you can get TDM for the same price or even cheaper? And what is happening with Sonnet Technologies is they're not staying still. They're going and making enhancements to their protocols, LCAS and VCAT and on those kinds of things, which are allowing us to squeeze more efficiency over these Sonnet networks. So previously you'd have a lot of stranded capacity because we couldn't, provision contiguous channels, or we couldn't find them. And all those things are making it possible for us to squeeze more efficiency over these Sonnet networks. And I believe that pricing is still under pressure.
Can I add one more thing, David, to your question is what Shankar said. LCAT and VCAS are primarily going to end up being on routers in the long run for offering the circuit emulated services. Right? That's, like it or not, that's where it's going to live sooner or later, and then customers will want to take advantage of that as well. The challenge is how do you do that over an IP switch network and offer that Sonnet-like service all the time, 24 hours a day, 365 days a year.
Where I've seen it is in applications that don't run over any of the normal layer 2s. Right. They've got some application that was built on X25 or built on 75 baud or something, and they really want to keep that application. So.
Good, thanks. Good question. Thank you. All right, so I got a question. Actually, I think it applies. It was going to be directed to Ted, but I think it applies equally to everyone. Was regarding the overlay network sort of deployment for this dedicated infrastructure to accommodate layer 3 VPN services, for example, as you mentioned, as opposed to deploying it ubiquitously and offering it on all your all your service interfaces, so that you don't need multiple local loops for internet access or other things. So basically, what challenges are there with offering like layer 3 VPN services, for example, on the same on the same device, the same box as you're offering native internet access or layer 2 transport services, that sort of thing. So just what are the challenges there, and why don't you do that today?
I'd say the primary reason for not doing it today is the customer set who want to buy those services are your enterprise customer base, and they are leery of being on a dedicated internet router, and they want isolation. So there is some level of isolation by dedicating the PE just to do layer 3 VPNs. Versus the layer 2 customers where you don't have an IP address in the box. Most of those guys are satisfied with the answer that it's not addressable via IP. So
I think to echo on Ted's comments, the primary reason is obviously shared fate. Customers don't like the idea or the notion that some large anomaly in the internet IPv4 unicast routing table is going to end up causing slow convergence on VPN. And vice versa, for that matter. Some of the internet customers are more sensitive than VPN customers. That said, there is work in the standards body to have, forget the actual term for it, I think it's multi-session BGP. There's a Scudder draft in the IDR working group, but that's going along the path of being able to separate out VPN IPv4 SAFI from the internet IPv4 SAFI, which is good in making progress. Then you need to start thinking about, well, do I have adequate CPU and memory to be able to, or separation in that PE? So really there's no easy answer. It really probably comes down to, can you afford to make them separate by buying separate boxes? And you know what, if you can, then all the more power to you. It's a lot easier for people to manage that way.
Okay, good. Let's go, Shankar.
I think one thing that we all can agree upon is that the interdependence of these applications, voice and VPNs and internet, are really increasing dramatically. So I think that really forces all of us to look at how we build these networks and have this physical separation, and think about how we separate out the VPN traffic and the non-VPN traffic from both the control plane and data plane perspective. And I think that's still work that where we're still trying to figure out how exactly we do that.
Okay, good. So I'm going to take a question over here next. Name, please.
Yeah, this is Karthik Muthukrishnan, Lucent Technologies. I had a question for providers rolling out MPLS backbone for layer 2 or layer 3 VPN services. Is there a convergence on either OSPF or ISIS? I mean, do you have any views on which one you're likely to use? What are you using right now?
Okay, so
ISIS.
Oh, Shane.
We can, Ted and I could probably sit here and chest thump over ISIS and OSPF and which is better, but quite frankly, they both work. If you're running MPLS, then quite frankly, it's not an issue. You're dependent on RSVP fast reroute for convergence reasons, and so when OSPF gets around to finding the next best path and rebuilding another LSP, the problem's over. But for you guys?
I don't run MPLS, so I'm not going to answer the question.
Yeah, at we use ISIS, and it's transparent.
Okay, yeah, so name and questions.
Sanjay Khanna from Tel Labs. I'd like to know on the MPLS fast reroute, it has been mentioned that it was a primary driver in some applications to go to MPLS. What are the ways you guys are optionalizing it? Like, are you using facilities or one-to-one? Are you deployed with node protection or link protection? And did you also configure backup LSPs?
That's a very long, multi-part question. So the answer is bypass and no, not backup. We're not using backup LSPs anymore. And I forgot, I'm sorry, the other part of your question, but we're not using node protection, link protection only.
Quest has gone through several iterations of this protocol from our vendors, and I think we are using bypass with link protection.
Doesn't apply to Ted, I know. Okay, so, all right, so yeah, one last question I got actually here is regarding the attentiveness that these services bring to vulnerability disclosures and exploits and that sort of thing in router, your routing infrastructure, right? So if there's a major vendor has a vulnerability disclosure, how much more attentive is that, and how much more does that affect revenue and other services and so forth? So. I don't actually want you to answer, by the way. We're going to talk about this at the NSP SecBoff tonight. So if you guys are interested, you can show up. So that's all I had. So, no, if you want to say something about that, any of you, I'd like to hear.
I think for converged networks, that are running both layer 2, layer 3 VPN services over an internet infrastructure where everything's shared, then you have to be a lot more attentive than if you run a separate dedicated network for it, as it were. So, I mean, there's really nothing more to it than that, really.
I would echo Shane's comments. The customers are a lot more forceful with their requirements for disclosure on what are the vulnerabilities, what are the security aspects, what are my risks, and they want to know that up front, and then they keep after you on it ongoing, and it never stops. Right? For those of you who are customers in the room, thank you very much.
Nothing significant to comment, unless Don, you want to say something? Okay.
Good. So yeah. So I want to thank these guys. The slides will be online. I apologize to Susan. She did ask me to have them, and we were late getting them. Ted and I were working on them out in the hallway a minute ago. So after I got him off the slot machine. No, I'm kidding. I'm joking. No, but anyway. So yeah. So Shane, Ted, and Shankar, I'd like to thank you, and so everyone at the NSP SecBoff for beer and gear, and give it to Susan. So thank you.